Good evening, colleagues, and we appreciate you joining in to our workshop that was shared to you. And thank you to Casio. Thanks to Lauren and Tim for making this session available to us as King Cetshwayo. Unfortunately, I can't see all the colleagues because most of them, they're just, no names have been written. I think that one they can organize after the session, that whenever they join the session, you don't appear as an unknown user, but welcome. I can see the others whose videos are on, Mr. Dekola, Zanele. I can see the other colleagues, so welcome and thank you very much. Note that Miss Madondo can't be with us. She lost her dad today. May his soul rest in peace. And hoping the other colleagues are still going to join us. And as such, fortunately, the colleagues are used to Zoom and Teams, so their mics, I can see that their mics are on mute, unless if you want to ask something, we unmute ourselves. And I think because we've seen each other, our videos can also be off, so that we we don't have any more interference. So as soon as the session starts, we can turn our videos off. Thank you very much, Karen and Lauren. Thank you.
Thank you, Nelly. Okay, welcome to everybody, and thank you for taking the time out in the evening to attend the workshop. I agree with Nelly in that turn our videos off. It just helps with bandwidth and things like that for everybody around us as well, for our networks. And as well as if you can mute your microphones. But if there is something that you're wanting to say, please bring it to our attention. Just unmute your microphone. And sometimes when I am asking questions, please contribute. It's always very, very nice to hear your input and your take on how things happen. I'm just admitting a person here. Hello, Sipelele.
Lauren?
Yes.
I think you can continue. When people are in the lobby, I'll admit them unless if there is a problem.
Are you able to admit them?
Yes, I am. I'll indicate
Okay.
if it's a challenge.
Perfect. No. I'm saying because I'm the organizer, so I'm not sure.
I am. I can.
You can admit. Okay, that's perfect. Thank you. That's fine. All right, so I'm going to be sharing my screen now. So I am just going to start with the workshop. Okay. For those that have seen me before, some of you might have seen me. Thank you for coming again. It's always nice to have repeat people because we always learn something new at all times. For those that haven't been able to join us, pass the message on that it's not as bad to do online sessions as many people feel it is. Yeah, it's something different and it's a bit of a new normal, as we call it. And those that have attended my session, it's a slightly different to my normal day-to-day sessions that I conduct when I'm at your school, because what we are focusing on in today's session is purely focusing on the trig. We're focusing on functions. I've got some stats as well as there's some financial maths available as well. So we are focusing purely on specific content. If we don't get through the entire workbook or the worksheet, don't worry, you will be receiving it later on in the week or early next week. So you'll be able to catch up on any missed content that we have not covered. And as I said, if you've got any questions, please feel free to unmute your mics and contribute. So the very first thing that I always like to introduce to everybody is, for those that are not familiar with it, our calculator. The most commonly used calculator in the South African schools at the moment is the fx-82, but the ZA+. Okay, the ZA indicates that it's made and manufactured for South Africans. So this is the one that we want to aim to get our learners to use in the classes. And for you as teachers to also start using it and encouraging the learners. So it's the fx-82, the ZA+ is what we're wanting. Okay, I'm going to take you through a few keys and a few functions before we start, so that you understand, have a better understanding on when I talk about certain keys, which one I am referring to. The very first one that I'm going to talk about is our shift key. Now, our shift key over here, you can all see my emulator. Okay, it's written in yellow as shift. Now, you'll notice throughout our calculator, we got various different yellow options that we can choose from. So whenever I say we are pushing shift, we are using something that is going to appear in yellow. Next to that, we have the alpha button. Alpha is written in red. Alpha is also an abbreviation for our alphabet. So you will notice that if we have a look on our leading negative sign, above that, we've got part of our alphabet, our A, B, C, D, E, F, and below that, our X, our Y, and our M. We also do have a few extra little, what I call third options to select, such as our random integer and our previous answer. So when I'm talking about shift, I'm talking about the yellow functions or options. When I'm talking about alpha, I'm talking about our red keys. Okay, the next thing I want to go on and discuss with you is the modes in our calculator. So when I push my mode button, mode is next to our on button, I push it and up come three different options. So option number one, or mode number one, is computational mode. Computational mode is our day-to-day use of our calculator, so our fractions, our decimals, time calculations, our plus, minus, times, divide, our trig, etc. Okay, then option number two, or mode number two, is our stat. And our stats is going to be for our data handling, and because we are all grade 12 teachers, we're going to do a little bit of linear regression, because linear regression can be made very easy if the learners know how to use the calculator. And then our third mode is our tables mode. Now, our tables mode, when we hear the word graphs, when we hear the word functions, when we hear the word, graphs, functions, completing a table, etc., we know we need to go into mode number three, our tables. There's one other option I want to show you, and that is our setup. To get to our setup, we are going to go shift and setup. Okay, here you're going to find we have 8 different options. In today's session, we're not looking at all 8. We are only going to focus on option number 6, our fix, and option number 8, our normal. So those are the only 2 we are focusing on in today's session. I also just throughout, I've got little reminders and little notes that I pop in to my worksheets during my training sessions. And I've made a note here, and it says, take notes. Please remember, there is a difference between our AC button and our on button. Okay, you'll notice your AC button. AC stands for all clear. And what I want us to encourage is for our learners, when they are clearing what is on the screen of their calculator, I want them to get into the habit of using the AC button instead of using the on button. And you're going to say, but what is the difference? Why can't I use on instead of AC when it does exactly the same thing? It clears what's on the screen of my calculator. And I will show you a little bit later in my session as to why I want to encourage you to use AC instead of using on. But just in the meantime, take note, there is a difference. Okay, use AC, avoid using on. What I always say to learners, especially before a test or an exam, is always check the following. Have a look at the top of your calculator. Make sure you have got the right setup. So what we need to see on our screen at all times is we want to see our D for degrees, and we want to see the word math. Now, feedback that we've got from various different departments and districts and things is learners, especially because they're borrowing calculators, they're not using their own, what happens is they forget or sometimes don't know how to properly use the calculator, so they don't check that they've got a D in a math, and sometimes they write the entire exam in a total different setup. So, for example, I can also find on my calculator screen an R and a G. Okay, we don't want these. The only thing we want is a D and a math. So what I advise you to do is we are going to reset or clear our calculator before we even begin. In order to clear or reset our calculator, Shift and number 9. Okay, a clear menu comes up. It asks you, what is it that you are wanting to clear? Is it our setup number 1? Is it our memory number 2? Or is it number 3, all our information? So I always say before a exam or before a test, clear all your information. We want to start from fresh. So option 3, clear all. It asks you a question. It says, do you want to reset all? If we press equals, we are agreeing, yes, I want to reset all. If I press AC, it cancels out and nothing is going to change. For today's session, I want us to reset all, so we are going equals. Just to confirm that everything you have done is correct, reset, press your AC button. Okay, now you will notice if you had anything different on your screen, it's all gone, and the only thing I've got is my D and my math. But we are not yet ready to use our calculator. What we need to also have a look at is often this happens. So I put into my calculator 1 divided by 800. And I press equals, and automatically, as you're all aware, up comes my fraction. Okay? I tell the learner, I don't want you to write it. I want you to convert everything into a decimal unless I ask you to keep it as a fraction. So they press their SD, and up comes a scientific notation, 1.25 times 10 to the negative 3. Okay, we don't want learners to, in maths especially, to write down in scientific notation unless we ask them to write in scientific notation. Learners are losing careless marks because what they see on the calculator is what they are writing down. Okay, they need to make sure that what they tell their calculator now is, please be normal. How do I please be normal? Shift and setup, which is there on our mode button. Okay, We want to please be normal, so we are looking at option number 8, normal mode. So I select option 8. It now gives me the option, do I want to be normal 1 or do I want to be normal 2? And very clear instructions. If you are doing physics, you will choose normal option 1. Those that are doing maths and maths literacy are always going to choose normal option 2. So for today's session, focusing on, we're going to select normal option number 2. What you will notice now, 1/800, when I press my SD, my answer is automatically going to come up as a decimal. Okay, a question that often gets asked is, do I have to do that every single time? No. The only time you're going to do that is right at the beginning. Once you have cleared your calculator, go back to normal mode 2. Okay, from now on, automatically all our answers are going to come up as a decimal. Okay, a section that gives us as teachers absolute grey hairs and nightmares, because we can teach them from young and we can tell them about rounding off, but some of them just don't get it. So we've got a function or a little feature on our calculator to help them with rounding off. So if I do a simple sum like this, I say 2/3 equals SD. And I now tell them or give them the instruction, round off your answer to 2 decimal places. Yeah. Many of them scratch their head or they nudge their friend and they ask them, what's 2 decimal places for this? Yeah, all we need to do, shift and set up again. What we are looking at now is option number 6, where it says to me, fix. To fix something means to make it right or to correct something. When we are asking learners to round off, we often say to them, write as correct to 2 decimal places or correct to 1 decimal place. Okay, so to fix is to correct or to round off. So we are selecting option number 6, fix. It comes up and it asks us, do you want to fix 0 to 9? That is asking you, how many decimal places from 0 to 9 do you want your answer rounded off to? We want our answer rounded off to 2 decimal places, so we are going to push number 2. What you will notice, it takes us back to our fraction. All we're going to do is press SD. And there you've got your answer now rounded off to 2 decimal places. But what you will notice on the screen of your calculator is you now have the word fix. Okay, you can press AC, you can press on, you can switch your calculator on and off as many times as you like. Fix is not going anywhere. Okay, which is a problem for us, especially, for example, in financial maths. Because in financial maths, we only want our final answer rounded off. And when I've got fix on the screen of my calculator, everything from here on out is going to be rounded off to 2 decimal places. So what I advise your learners is to only use fix when they have come to a final answer and when they are checking. Okay, how do I get rid of fix? I go back to normal. So shift and set up. Option number 8, normal. And exactly as before, normal option 2. Now you will notice fix has gone off the screen of my calculator and I am back to my unrounded answer. Okay, getting into some trigonometry. When I'm talking about our trig functions that we're looking at today, we're going to be using the following keys: our sine, our cos, and our tan, as well as our sine -1, cos -1, and tan -1. So I've got over here, let us start with our basics. So what we can see over here is we've got our triangle, and it shows us our hypotenuse, our adjacent, our opposite, and it gives us our rules. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, and next to that I've just put our little identities there. Okay, I'm starting with the basics and we're building up slowly on this. Okay, find the value of the following. Sine 45 degrees. All you are going to do, you're always going to work from left to right. So sine 45, and you close your bracket, because notice after your sine, your bracket automatically opens. A question I get asked sometimes is, do I have to close the bracket after the 45? You don't have to close the bracket after the 45, but me being a teacher, I like things done as I would write it down in my book. So on the calculator, what I would put in my book is what I put onto the calculator. So sine 45, and so sine of 45 is equal to the square root of 2 over 2. If you ask your learners to now write that as a decimal, they can take it from their fraction into their decimal by using our SD button, and we can go back again by pushing our SD. Okay, question number 2, something a little bit different. So what we've got here, or what we've been given here, use the triangle below to find theta. So there's our theta. We've been given our 5 kilometers, we've been given our 10 kilometers. So what we've actually got is we've got opposite and adjacent. So we've been given our opposite and our adjacent sides, therefore we will be using our tan. But because it is theta, or an angle that we are now looking for, what we have to do is we have to press our shift option. So shift and tan. Okay, what we're now going to put in is we use our identity, so we use our rule and we say tan was opposite, so it's 5 over my adjacent, which was my 10 kilometers, and I close my bracket. So what this is going to indicate to me is what is theta. Press equals, and there is your answer. So 26.57 degrees. Okay, so always remember your sine, your cos, and your tan is for when you are working out your identity, and your sine -1, cos -1, and tan -1 are going to be used when you are finding an angle. So that is the difference between those two keys, or those functions. Okay, something a little bit different. Let us apply this to an exam situation. So what you will notice throughout this session today is I've taken from 2016 through to 2019, I've gone through paper 1 and paper 2, and I found examples where we can apply calculator usage and use the calculator to assist us in finding and being more accurate, as well as to save our learners time, because one of the most common things that you will find amongst maths course students is that they never have enough time to check their work, and they never have enough time to finish an actual exam, or often they don't. So the calculator is going to show them how to be more accurate and how to time save for them. So what we've got over here, in the diagram below, we have got our P, and P says to us we have got K and 1 as our coordinates. It then goes on and it says this is a point in the second quadrant, so we know we're looking at our negative there, and is square root of 5 units from our origin. So if we look at that, that becomes our hypotenuse. Our hypotenuse would then be square root of 5 units. R is a point on the positive x-axis, okay? And obtuse, R-O-P, so R-O-P is my theta angle. 5.1.1 says to us, calculate the value of K. Now, to find the value of K, what you will notice is, as I mentioned, we've now got a hypotenuse, okay? We know that our height over here is going to be 1, but we don't know what our base of our triangle is going to be. So we need to apply the Pythagoras rule. How can we do this, or how is our calculator going to do this? Because often what we find is our learners do not finish this question off nicely because they come to a point and that's what they think the answer is going to be. So K squared equals, open your brackets, square root of 5. Now, you must remember that when you are finished using your square root sign, you must use your replay button to move you across. Otherwise, everything stays under our square root sign, and then we're changing the question completely. So, square root of 5, close my brackets, it is squared, and minus 1 squared. All we're going to do now, press equals, and this is where our learners, they write down 4 and they say K equals 4, which is incorrect because K is not equal to 4. K squared equals 4. What we now need to do is we now need to go square root of K and square root of 4, and equals, and we get our answer of 2. So therefore, K equals 2. But if we refer back to our diagram, K is on the negative side. It's in our second quadrant. So therefore, K is negative 2. Over here, 5.1.3. Use the calculator, okay? So this comes out of an exam. Use a calculator. They're encouraging you to have a resource and use it to calculate the value of tan theta minus 40 degrees. Correct this to 1 decimal place. Let's see how this one can be done. So there's quite a bit of working out, and quite a few steps, even though I am using the calculator. So calculate theta first. So in order to do this, we know we've got tan theta. So what we are looking at is our angle. So shift and tan. Notice how again it automatically opens my brackets. Okay, I have got minus a fraction of half, and I close my brackets. And all you're going to do, press equals. And there I get 26.565 or 26.57 degrees. But we have not finished our question or answered our question 100% yet. So we need to go on now and say theta equals 180 degrees minus 57, which equals to, and we're going to convert that to our decimal, 153.43 degrees. We still haven't finished our question because we now need to put all of this together. So we need to know now tan 2 theta minus 40. So tan. Now I'm going to open a second bracket over here, and I'm not doing it by mistake. I will explain at the end of this question as to why I have opened my second bracket over there. Okay, 2 times 153.43. I am closing my bracket, minus 40, and I am closing a bracket there as well. Okay, I'm pressing equals, and there I get 18.2287921. Okay, if a learner does not know how to round that off or how to follow instructions, they are more than welcome to go and fix it. So just to show you that even when we are in a question, we are able to fix, and there's our answer, 18.2. Just go back to normal. Okay. Now, I said I'd come back to explain why I opened a double bracket here. Okay, bear in mind that the reason I've opened a double bracket is because when our learner or a learner would have been writing this down, they would have used a nice big square bracket. Okay, but our calculator doesn't have square brackets. So what we are going to use are our round brackets, and we are using 2 of them. Okay, so there I've done one part of my question and closed it off, and there is my final part of my question and closed it off. If we don't put the different brackets in, our answers come out incorrectly. Okay. Now, before I continue, I just want to show you something over here. I mentioned earlier about using our AC and our on button and the difference between them. Now, you would have noticed that the entire time what I have been doing is when I clear my calculator, I'm using AC. Okay, as I said, our learners have quite a bad habit. Even some of us, I had to train myself even to stop using the on button. Okay, and let's have a look at what is the difference between AC and on. If you have a look at my calculator, I've got my D there, I've got my math, and I've got a little triangle, as learners call it, the little triangle. And often the hands go up, ma'am, I don't have a triangle. Okay, the reason you do not have a triangle is because they have used the on button. So when they've cleared their screen, they have pressed on. The reason I have a triangle is I have used AC. And you're going to say, but that still doesn't explain what the difference is because your screen has been cleared. Okay, we match it up. We've got a little triangle over here. And on my replay button, I've got my other little triangle or my up arrow. And that's actually what that is. It's not a triangle, it's a little up arrow. I can push that arrow up and I can see what I have done in the past. So that was the last thing that I did. So I did the question twice. Once was with rounding, one was without. I can go back and we can see the entire time what I have done. The reason I can go back so far, I've gone right the way back to the beginning, is because I have used AC. Let's have a look. What's going on? happen when I use by information? Okay, I have no way to go back and see or recall what I have done in the past. Okay, so that is your difference between your AC and your on button. Something else I want to talk about is a syntax error. This often occurs, trig, financial maths, and time calculations. So I'm just quickly going to put in, just to show you what happens in a syntax error, I'm just quickly going to do a time calculation here. Okay, and up comes a syntax error. If you see a syntax error, what this means is that you have made an error with the sign or a symbol in your question. So it might mean you've left off a bracket that is relevant. It might be you've added in too many brackets. It might be that a sign is wrong, so you might have put too many negatives. Okay, you might have put 3 negatives instead of only 2 or 1. So what it is, it's a sign or a symbol that is causing our error. Now, most of the time, I'm always very aware when a learner gets a syntax error, because shock, horror, oh my goodness, they don't know what to do, their calculator is not right. They look around and they look at me and their big faces, and what they always go and do, up comes the finger, AC, 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 on, switch it off, switch it back on, make that problem disappear. Okay, AC cancels everything out. Yes, it makes the problem disappear, but what happens in the process, it clears off everything I have put in. So if I've got a long financial maths question that I've done, the last thing I want to do is press AC and start all over again. So what can I do? Below where it says AC cancels everything out, we read over here and we see, I've got a left arrow and I've got a right arrow, and it tells me to go to. Yeah, I can use my left or my right arrow on my replay button, and I can go to where my mistake is. So left, right, it makes no difference. I press it, and where you see your line or your cursor flashing, that is where you have made your mistake. Okay, so in this situation here, I know I did it quickly, and it's a thing that we will do on another day as we'll discuss time and things like that. I correct it, I press equals, and oh no, another syntax error. Okay, why did I get another syntax error if I have already corrected my mistake? The reason I am getting another syntax error is because it's my calculator telling me you have made more than one mistake. So again, left or right, no difference. I press it, and there my cursor goes to the end. That is where I have made my second mistake. So what your calculator does, it takes you to your very first mistake, you correct it, it will then take you to your second or your third or your fourth until you get a perfectly good answer. So that is the idea behind your syntax error. Use your replay buttons, your go to, instead of using AC. Go to my mistake. Okay, a commonly asked question is, because learners especially, they see this written in their exam papers, or we write it on the board, and we write it as cos squared 45. Now, if I go and I put cos, side, but did you know that cos squared 45 is actually exactly the same as cos 45 squared? So if we put that into our calculator, they mean exactly the same thing. So cos 45 squared is exactly the same as cos squared 45. Equals, and there is my answer. Cos squared 45 equals a half. Another thing that often we come across is a math error. And this here is, we are often going to see it in our trig questions, and that is intentional, because a math error, if I go tan 90, close my brackets, equals, up comes my math error. And even if I go to, it's not going to take me to an exact place, because what that actually means is that I have not made a mistake, but my answer is clearly undefined. Okay, so that is what my math error is. A math error means my answer is undefined. Does anybody want to say anything in the meantime before I move on, so that I've covered the basic trig functions there? We're going on to normal functions now. Anybody want to comment? All right, let's have a look at functions. So, what is a function? A function relates to an input and an output. So, every now and again, we decide that we're going to give our function a name. And majority of the time, we're going to name two functions or use two functions, and that is going to be our f of x, and we're going to have a g of x. Those are the two functions that we are going to come across. So, how can a calculator assist us with our functions? Let us have a look at a few examples. I'm starting with the basics, and we're building on to quite a difficult exam question. So, I want you to, if you get lost, please let me know. Okay, so just shout at me and tell me, Lauren, I don't understand what's happening, go through it slowly. Okay, as I said earlier, when I hear the word functions, I am going to go, functions are graphs, functions can be tables, okay? So functions can be coordinates. So any of those, the moment I see that word functions, graphs, coordinates, tables, I know I need to change my mode on my calculator. So what I need to do is push my mode button. I now need to say I am going into option 3, table, and automatically you will notice up comes our f of x. Okay. We have a question that goes as follows. Complete the table of values to graph each function. So f of x equals x squared minus 6x plus 5. And we've got our table, our x values have all been given to us. We need to find our f of x or our y values. So the very first step that we are going to do, we need to put our function into our calculator. Now this is where we are going to have fun with our alpha button. Please, 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 I beg you with tears in my eyes, this button over here is a multiply sign. Please don't use it as an X, okay? Yes, it looks like an X. I admit to that, but it's not an X, it is a multiply sign. So please be aware of that. Okay, when we are looking at the X that we are wanting to use, we are using our alpha button and we are using our red X, which is found over here on our closed brackets. So alpha and x, which is found, as I said, on my closed brackets. And now the question said it was squared. So alpha x squared. Okay, minus 6. I need to put an x in again. Alpha and x plus 5. So x squared minus 6x plus 5. Please can I ask you as educators, remind your learners, it is very, very important. What they have put into their calculator matches up with the question that has given. I have come across many different students in my sessions and feedback from teachers and things like that, even from examiners and markers, to say, Lauren, these people are not checking their work. They know it, they've done it, everything is right, but finger troubles. Okay, so when they're putting things into their calculator, instead of putting a 5, they may be putting a 4. So please get your learners to double check that what is on their calculator matches up to what is in the question. Okay, we press equals once we are happy with everything. Equals acts as our enter key. So like we would push enter to go to the next line on our computers, we're pushing enter to go to the next page or page on our calculator. Up comes our option of g of x. Now this function is very, very nice on our calculator because we're able to do 2 graphs at exactly the same time. And from grade 10, 11 and in grade 12, we sometimes ask our learners or give them the instruction, draw 2 graphs on the same set of axes. Okay, this function here comes in very, very useful because they can do both at exactly the same time. Okay, if I don't have a g of x or a second function, that is perfectly fine. Don't worry about it. Okay, some learners have a very bad habit. They want to put a 0 in there because they're saying, man, there's nothing there. Okay, no, we do not put a 0 in there. We leave it blank. We press equals. We just say, I don't want you, let's go next. Okay, I'm going to take a break from the calculator quickly, and I want to just discuss a few little notes that I've got written here. Okay, your calculator, as we saw, comes up and it asks us a question. It says, where do you want to start? Okay, the next question it's going to ask you is, where do you want to end? And the last question it's going to ask you is, what is your step? Okay, let's look deeper into what is a start, what is an end, and what is a step. Okay, what is a start? A start is, this is the point you would like to start at. So if I go back up over here and have a look back at my table, generally what we use the rule to be, there is no rule as such, it's just a guideline, is we always start with our lowest x value. So in this situation here, we're going to be starting with 0. We then go on and it asks us, what is an end? Or where do I want to end? Okay, this is the point you would like to end at. If we've started with our lowest x value, which is 0, we're going to end with our highest x value, which is 6. So your rule of thumb, start with your lowest, end with your highest. And then we're going to get asked, what is a step? Your step is your intervals that you want to go up by. So if we look at this, let me explain it, because lots of learners get this wrong. Lots of learners say, oh, I went from 0 to 6, it means I took 6 steps. No. Okay, what it means is, how did I get from 0 to 6? Who did or how how did I get there as such? So I started with 0. From 0, I didn't go all the way to 6. I had to bypass people along the way. So 0 to 1 was 1 step. 1 to 2 was 1 step. It's not 2 steps because I'm going 0 to 1, 1 to 2, 2 to 3. That's another step. Okay, so that is where your step comes in. So every time I'm taking a step, I'm going 1 step at a time. So let's have a look. How can we put this all into our calculator? Remember, you are the boss of your calculator. Your calculator is going to suggest starting and ending points, and it's going to save information along the way. You are the boss of your calculator. You need to make sure that you are where do you want to end and what is your step. Okay, we're going to use the table because we want to complete our table. So we are starting with our lowest x value of 0. So 0 equals, and we are ending with our highest x value of 6. Okay, your calculator suggests you're ending at 5. No, I don't want to end at 5. I want to complete my table, so I need to end at 6. So 6 equals. As I indicated, what did we step in? We were stepping in ones, so step 1 equals. Now we can go and we are able to fill in our table. So let's have a look. How do I read this? My first column that I am looking at over here, they are all my x values. So if we have a look at our table that was given, it went 0, 1, 2, 3, 4, 5, and 6. If I look at my x values that I have on my calculator, they match up. 0, 1, 2, 3, 4, 5, and 6. So my first column that I've got here are my x values. My second column are my f of x or my y values. So I can now go 0 and 5. I can go 1 and 0. I'm going to look at use my worksheets, otherwise I've got to pop that up and down the whole time. 2 and negative 3. 3 and negative 4. Okay, 4 and negative 3. 5 and 0. 6 and 5. Okay, so there we have our table that has been completed using our calculator. So that's the first thing that we are able to do. That's the basics. Let's go on and look at a little bit more different type of question, because learners get confused with the way we ask the questions. So draw the graphs. So we've completed a table above. Now it says to us, draw the graphs of f of x equals x squared minus 6x plus 5 and g of x equals x minus 1, given that x is greater than equal to negative 1 but less than equal to 7. Draw them on the same set of axes. Now, this is where I say to you, show you. Okay, the difference here between our AC and our on button in our tables mode. If I press the AC button, it takes me back to the beginning and all my information is still there. If I press equals, nothing has changed. Okay, but if I press my on button, my f of x and my g of x will both be removed. Okay, so now I've got space. I can enter in my f of x and then enter in my g of x. Alpha x squared minus 6 alpha x plus 5 equals. It now asks me for my g of x, or my second function. Do I have a second function? Yes, I've got a straight line. Alpha x minus 1 equals. Now the learners always say to me, oh goodness, ma'am, you didn't give us the table. We haven't been able to see our set of axes. So how do we know where to start and end and what our step is going to be? I say to them, refer back to the information that has been given to you. You were told x is greater than equal to -1 or less than equal to 7. So start with your lowest x value, end with your highest x value. So I'm in this situation, I am going to start with -1 equals, and I'm going to end at 7 equals. Generally, we like to step in whole numbers. You can change it. So if you are wanting to zoom into greater detail of your graphs, let's say, for example, there's information that you can't find, what you can do is you can make your steps smaller, so they can be your decimal values. Okay, but generally we like to make our steps 1, unless obviously it's a trig graph. I press equals, and now learners panic a little bit because they say, oh goodness, I've got 3 columns, why do I have 3 bits of information? Okay, I always say to learners, use the finger rule. Take your finger and block out what you are not using. Okay, so for example, I will take my finger, I'll put it where g of x is, and I will hold it there, because then I know I'm not using my g of x right now. So all I will do, I will or my ordered pairs, so that it's a parabola. So I will start here, -1 and 12. Okay, it's up the top over there. 0 and 5. So 0 and 5, and I've plotted my points. 1 and 0 on my x-axis. So there's my x-intercepts. Okay, 2 and -3. 3 and -4. Oh, look at that. We've got a beautiful turning point given to us. Okay, 4 and -3. 4 and -3. 5 and 0. There's our second x-intercepts. 6 and 5. 7 and 6. Yeah, which has gone up the top. All right, so what we did over there is we used our x values and our f of x in order to draw my parabola. Okay, what I will now do, I'll take my finger and I'll say, I'm finished with my f of x, I now need to use my g of x. Take your finger, block out your f of x, and what we're going to do now is jump across. So x is -1 to -2. Okay, I've then got 0 and -1. 0 and -1. 1 and 0. Okay, 2 and -3. 2 and -3. Sorry, 2 and 1. My apologies. 2 and 1. 3 and 2. 3 and 2. My graph has changed direction here. 4 and 3. So 4 and 3. And 5 and 4. 6 and 5. So there you'll notice there's a point of intersection where my 2 graphs should be cutting. Okay. And 7 and 6. So there you are able to use your calculator in order to do your 2 graphs. All right, let's have a look now, get into greater detail. Let's apply this to an exam situation. So question 8 reads, the graph of f of x equals negative x cubed plus 13x plus 12 is sketched below. They then tell us A, B, and D are our x-intercepts. They tell us that D is negative 1 and 0. They then tell us that C is the y-intercept of our f graph. But they then go and ask us, 8.1 says write down the coordinates of C, and 8.2 says calculate the coordinates of A and B. So I always get the learners when I give them a question like this, that exact face is given to me. Oh my goodness, nothing has been given. The only thing I know is that negative 1 and 0 is D. I don't have X values. I don't have Y values. I've got nothing. Okay, don't panic or do not fear. Your calculator is near. All right, take a nice deep breath and let's see how can our tables mode help us out. So I want to clear off what I've got there because I'm starting a new question. So I press my on button and up comes my f of x. Okay, we were given all our information up here. So f of x equals negative alpha x cubed plus 13 alpha x plus 12. Again, please remind your learners just to double check exactly what has been given is on the calculator. I press equals and it asks me for a g of x. Do I have a g of x? No, I don't have a g of x. So I press equals again. It now is going to still ask me for a start and end and a step. Okay, can anybody tell me, unmute yourselves please, and tell me or give me an idea, where would you start, end, and what would you feel your step is going to be? Is anybody brave enough to tell me? Okay. So you are saying value says to me, I've got 12. So the suggestion was, can't I just look at that 12 and go, well, I'm going to start with a negative 12, and I'm going to end with a positive 12. Okay, and I'm going to step in ones because I want to see every bit of information I can get. I press equals and, oh dear, I come across a little bit of a snag where it says to me now I have got insufficient memory. Okay, the reason for that is what we need to do is we are not able to go and put in all our information. So it's not able to hold everything. Okay?
Lauren,
so what?
Lauren?
Yes.
You're no longer sharing the screen.
Sorry?
You're no longer sharing the screen.
Am I not sharing the screen? Okay. I don't know why it stopped sharing. Am I sharing? Okay, thank you. Okay, so what I've put. Okay, so what I did, I said over here, the suggestion was that I look at my constant and I go, okay, let's start at a negative 12 and end at a positive 12, because why not? That's what's there. So I used my constant and I said, I'm starting at negative 12, I'm ending at 12, I press equals, I'm stepping in ones, okay, and up comes insufficient memory. Okay, insufficient memory because the range of my graph is too big for all of the information to be held on my calculator. So what this means to me is I need to change my start and my ending points. So in order to do that, I've gone back to the beginning. Notice I'm using AC when I go back. Okay, I go back and I look here and I say, if 12 didn't work, maybe I can reduce that down. Okay, and remember that just because no information was given to us, our start, our end, and our step are purely guidelines for us. So you can actually choose where you want to start, end, and step. Note, guys, please, very important, this graph that we've got in front of us, that there is not drawn to scale at all. Okay, it's way off scale actually. So what I have done, I have decided that I'm going to start with a negative 4 and I'm going to end with a positive 4. So I'm starting with negative 4 and I'm ending at positive 4. You could choose any values to start and end with as long as you do not get an insufficient memory. So don't make that range of answers too big. Okay, my step, I'm keeping it as 1. I want to try and be as accurate as possible. So I press equals. Okay, what I've now got, negative 4 and 24, negative 3 and 0, negative 2 and negative 6, negative 1 and 0, 0 and 12, 1 and 24, 2 and 30, 3 and 24, 4 and 0. Okay, so let's go back and have a look at the question and what it was asking. So they said to us, they wanted us to know what is 8.1. They're asking for our C. Our C was our y-intercept. So what do we have to have a look for if we are dealing with a y-intercept? Okay, where our x value is 0. So I find where my x value is 0 and 12. So my C coordinate is going to be 0 and 12. They then asked us for our x-intercepts, okay, our A and our B values. For our x-intercepts, we need to look and we need to find where is y equal to 0. So we can have a look over here and we can say y is equal when it's negative 3 and 0. So that's our A value given to us. We can keep scrolling. Negative 1 and 0 was given to us. That is our D value. Okay, that we note. So at least we know we are on track. And we keep going and we say, oh, look over there. Okay, 0 and 4. 4 and 0. So that is my B value. Now, I want to take you back up here because I've got a little means no marks. Use a calculator to check your answers and also to help you along the way. The reason I put that there, if we look at 8.2, the is 5 marks. Okay, we need to make sure that our learners still understand what they are doing in order to find our A and our B values, but that they are able to use the calculator to scroll through and check their answers. Okay, often also you would have seen in many different trig questions, it'll say without the use of a calculator. Okay, the learners can still use a calculator to check their answers. The only thing we don't want them to do is not show any working at all. So please, they are allowed to use a calculator to check their answers, but obviously they need to show some form of working out in order to get all their marks. Okay, question 6 over here. It says, in the diagram, the graph f of x equals cos 2x is drawn for the interval x equals -270 to 90 degrees. Okay, so here we are dealing now with a trig graph or trig function. So there you can see it's beautifully given to us. Okay. And in 6.1, the question then goes on and it asks, it says, draw the graph of g of x equals 2 sine x minus 1 for the same interval, -270 to 90. On the grid given in your answer booklet, show all the intercepts with the axes as well as the turning points. Okay, so we've been given a lot of information of what it is we need to do. Okay, because the first graph is already drawn for us, we don't need to worry to put that in. You can put it in, okay, but there is no need for it. What we are going to do, where it says g of x equals 2 sine x minus 1, this we are going to put into our calculator. Okay, and I want you to pay careful attention to this. So if I go and I do this, 2 sine alpha x minus 1, and I close my brackets, is that correct?
No.
No, okay. That is not correct. What we've done is we've changed the entire question. So what we need to do is we now need to tell our calculator, what is it that we are looking at? We are looking at the sine graph. So once you are finished, after your x, close that bracket, okay? And then you tell it, minus 1. So basically you are telling it we've got 2 sine x is the graph we are looking at, but we've got a movement, so -1. Okay, so I put that into my calculator. Just a reminder, please remember that there is a difference. Okay, very, very important. I press equals. I'm not putting a g of x in because our first graph was drawn for us already. I'm now looking at starting and ending points. It was given to us beautifully over here. Basically, it tells us we are starting at -270 equals, and we are ending at 90 equals. Okay, here comes the part where we normally have a really nice discussion with our learners, because the question is, what am I going to step in? Okay, does anybody have any ideas for me? What can I step in? Is anybody there? I can step in 90s because it's basically told us negative 270, negative 180, 90. So it's basically given us the step, or showing us the step of 90 over there. So I can go step of 90 equals, and there I get negative 270 and 1, negative 180 and negative 1, negative 90 and negative 3, 0 and negative 1, 90 and 1. Okay, so that there has given us all our different indications, and but it's not telling us, or it's not showing us where are we actually cutting our axes, and that's what the question was asking. Show all the intercepts with the axes. So that step that we have used of 90 is actually too big. Okay, so what we now need to do, we need to bring our step right the way down. So what I am going to do, I'm going to step in 30s. I'm going to say 30 equals, and let's have a look at what it's going to produce. Yeah, I've got negative, got already. Okay, negative 240, and we don't like dealing with numbers like that, so we're not going to plot that exact point, but it gives us an idea of where we are heading. We know we're going down. Negative 210 and 0. Oh, look at that. It beautifully shows us where we are cutting our x-axis. So there's our intercepts. Okay, negative 180 and 1. I'm sorry, negative 1. Negative 150 and negative 2. I've then got negative 120 and just above my negative 3, sorry, negative 90 and negative 3. Oh, look at that. There again, we've got a lovely turning point illustrated for us. Okay, negative 60, we're going back up. Negative 30 and 2, and negative 2, 0 and negative 1. There we go. We've got our y-intercepts. 30 and 0. We've got our other x-intercept, and we can finish it off with our 90 and 1. So just be aware that that is how we are going to use our steps as a guideline, or even our starting and our ending points. We use them only as a guideline. Okay, there is no rule that says you have to start at such a point. Yes, in this situation, it came in very useful to start at negative 270 and work my way through 90, because that's, we wanted to fill that graph, needs to fill that entire space. Okay, so the start and the end we could play with, but the start and the end had to stay the same, but our step had to be adjusted. Okay, again, I'm going to just quickly show you if our step is too big, okay, if our step is too small, what is going to happen? Insufficient memory. Okay, so if our step is too small, we're going to get an insufficient memory. The moment we get an insufficient memory, you've got 3 options. Change your start, change your end, or make your step bigger. In our situation, we want to make our step bigger. Okay, and that there, again, it was a really nice exam question that was done. Just want to ask before I continue, we've only got 5 minutes left. I'm aware, because I can hear in the background when people are leaving, there are quite a few people that have left. Do you want me to go on and start an entire new section of stats, or can we maybe round up now with the 4 minutes remaining? Because I don't want to get kind of like halfway through a section and have to stop. What is your input? Yes? Yes, that's what I'm thinking, is because there's still stats and financial maths, and in the stats I do data handling and we do linear regression, so that there can maybe even be a section or a session in itself. So I think instead of going and starting an entire new section, those that would like to attend, we can always schedule a date for them to attend and a time for them to attend to carry on going through the worksheet. Nelly, what is your opinion?
Karen, I will support the rescheduling, because if you can start a new section now, and I think that the pace that you are doing your workshop, the information that you are sharing, it's so much of it. So, yeah, to avoid even the overload, because this is interesting actually. So let's
okay. Perfect. So I'm going to stop my screen share now, and what we're going to do is just round up. Okay, so yes, thank you very much. I see there's still a few guests on board. Thank you to those that have stayed. Just to pass on the message to you, I didn't mention it earlier to the first session that took place at 11 o'clock, because we wanted it to be a nice big surprise. But those that have stayed for the entire 90 minutes, basically you will be dealing with Leslie and Nelly, and you will be receiving a Casio calculator, the fx-82ZA Plus. Okay, so you can pass that message on, but it's only those that have stayed for a majority of this session. So thank you very, very much for your time. I hope you have learned something. We will also be sending you in the near future, probably on about Monday, so just give us a few days to get back on our feet and things like that. We will be sending you the workbook, because I call it a workbook because it is 19 pages long at this point in time, and we will be sending you a feedback form. Okay, we would really appreciate, or I would really appreciate your feedback on that feedback form, because I need to know what content did you find relevant, what content would you still like to cover, if there's a section in general that you are extremely interested in. That would be a great idea behind that. So also you can, in your feedback, tell me you went too fast, you went too slow, you found it informative. You need to tell us, how did you feel about that? Okay, so I'm going to say thank you very much to all of you for attending. I know it's now quite late, and I know it's after hours, but I do hope it's something. So thank you very, very much from me. Nelly, do you want to say anything?
Yes. To the colleagues who've attended and who have stayed for the duration of the workshop. And Lauren, to speak the truth, I've attended your sessions in conferences, but this one, I think when you are in conferences, you are under pressure. You are
Yes.
time. But now you took your whole time explaining every aspect. So thank you very much. It was a worthwhile session. And thank you.
Thank you, Nelly. Thank you for standing in as well. I do appreciate it, and I have sent my condolences on to Leashley as well.
Yes. And the other thing, maybe Lauren, as we are saying, you need the feedback. Maybe in the next session, you design a form and you share a link by the time before we even leave the session. Allow the colleagues to complete the survey or the feedback form.
Okay, that's a good idea. Thank you. All right, so thank you very much to everybody. I'm not sure who's still here. I see everybody's mics are off and screens are off, but I hope you have a great evening, and I look forward to seeing you guys again soon.
Thank you.
Thank you very much.
It's a pleasure. It's so nice to have you.
Okay, thanks.
Pleasure. It's an absolute pleasure. You too. Thanks, Astrid. I appreciate your help.